Alright, let's move to the fixed pendant. Okay, we can jogging by first of all we have to change it to the manual mode, and then we click on the enable to give the motor on, and then we can jogging the robot like this. We can jog, we can move it like it's like a joystick to move the robot by manual. And then I'm going to show you the code that I set up from the create target, and move the target to the path, and then it's gonna give you a programming code, give you a code automatically, or you can jogging the robot and set the position by give instruction. I'm going to show you how to use this. So first of all, the first code, this construction home is a robot target that I created. It's like a robot. It's like a home position that I set up the coordinate system. You can see on the number 451 and 700. It's like a robot home position that I set up, and it's gonna, when we cancel the simulation, it's gonna move back to the home, and then robot target another target. It's like just this is a simple code that we can set up the coordinate system of robot by we can give them a fixed coordinate, or we can jogging around here and use the set position, and then move buffer. It's like a coordinate system too, and then I'll move on to the main loop of code. It's like a move j home is linked up to the above. It's like a move j and then move to the coordinate system home that we setting up from the other process, and we 500 and set 100 is like a default of value of robot. And then we move to the other loop. This loop is a loop to call the function module in the main part. Set do, I set is like a do system to grab the work, and where gi is a delay, is a time delay. When it move to the workpiece, it's gonna waiting for the 1 millisecond to continue to work, and then when we waiting the 1 millisecond, and then it's gonna picking up and paste down. It's a loop of working of robot is here, and then it's end the loop by ny, and this is a function that we pick up for in the above. So the first function, I move j and I move to rail 2 is a gripper, and I set the coordinate system from this, and then move j is a move joint of robot. It's like a move joint, move the axis, and move out is move linear. We can move everything. We can move the workpiece, we can move the robot by the linearly, and we wait 1 second, and then we move it to the another coordinate system that I set up, like like this is our first coordinate and this is the second coordinate, something like that. And then we move buffer. Move buffer is we move the in effector, the uh, uh, the final joint, the joint 6, and we setting up 2, and then we move joint, we move linear, and we can wait for the sensor. Like I said, when the workpiece move on the conveyor and it suddenly found the sensor, it's gonna stop. By this line of code is give the sensor to detect the workpiece, and then workpiece and the conveyor gonna stop, and then move the robot to that by paste down. You can paste down. I use the name of function is like a paste down to paste the workpiece, and then when finish everything we can move J home and waiting for the next process, the next workpiece they're gonna use to setting up, and then we call the position. It's like a label. It's like a label to show the position of robot. That like a X position move to the 300 coordinate system, something like that. It's gonna show us where the robot is. So this is the end of this robot, and this is the data. It's like a to data and low data, and yes, input output is setting up as a default and calibration. Nothing to do. Control panel, thing to do. So this is the overall overview of how to use the freight pendants, and I want to show you how you can create a simple instruction. Like if you want to move the robot, we can use it's like a add instruction right here from the program editor, and then we can use the move out, like I said, move linear, and then you can use the move J to move joint, something like that, and you give it like a part, or you can join by manually, something like this, and then you move it on this, and you can set it position, and it's automatically to give you a code like a move J 500, move L 100, something like that. All right, and then we move to the another robot here. The another robot you can show on the frequency too. The code of the other robot is the same too. Is the same. Right, we can fit like this. Okay, okay. You move join. Alright, it's moved. Okay, and then let's move to the program. Let's move to the code. Alright, it is the same too. It's the same as we first we assign the condition. Robot target is the same as the same course as previous that I show you. Robot target home pick buffer to pick up the work and pick up the object, and then we press the object, and we give it a palette the label of X position, Y position, that the position show us where is the robot is, where the robot's at. X pitch is like a home position that we setting up. on the XYZ and X offset. That X offset is like I use the limit of robot, limit of work. That robot not move uh, over the offset that we set up. And then let's move to the loop. The main loop, we the same. Pick up. We pick it up. We move join. We move linear, and we call the function that we have created by the target, create target and create path, and move the target that we create to the path by the give it construction. Like we can teach the robot, we can give the robot the instruction, and it automatically give us the code on the fixed pendant, and we can adjust, we can change the code to move to the coordinate that we have to, that we want. Alright, that is the same code as previously, right? And we can end for the for loop, can use the loop. Alright, this is the overview, the overall of the how to use fixed pendant to jogging a robot, and to teach and to give them instruction to move the robot to the coordinate system that we want. Next step, I'll show you how to simulation and show us the result of signal analyzer. The signal analyzer is a graph to show the operation of work, like a work cycle, like a velocity, like a power that uses on this working. So we have to set up the signal. So in this case, I'll show the total model power and the speed of work. Alright, and then we click on play simulation, and then we show the signal analyzer, give it on this, and then when robot move, you can see on the right hand that I give you a graph of analog signal. The analog signal is a speed, velocity, that you can see when the robot move to pick up. It's fast and slow. It's slow when it's gonna slow down when it pick up the workpiece, and then is power, that the power uses on the work of the robot. You can see it on this, and this is a recording of analog system of work.